When you first start programming with AI agents, you would say something like that. Please fix this or please build that. But then as time goes, you try to follow the tricks and tips on how to optimize your workflow. They would tell you to run 8 AI agents simultaneously, to have complex orchestrations between multiple agents, to chain agents together, to have custom sub-agents, to have a library of 18 different slash commands. After that, you realize that the more you cut this crap from the context, and the more your context is neat and organized and clean, the better results you have. And then you end up with something like this. Hey, look at these files, and then do medium-sized change, so it's not a large full stack feature. So you kind of move along this curve. At the beginning, you don't know anything, you do not have a workflow. Then after that, you start complicating and overcomplicating things. And then you come to a realization that actually the simpler, the better. So this is actually my story of working with AI agents for programming. And this graph is taken from the blog of Peter Steinberger. And if you haven't heard of him, he's the creator of OpenClaw or CloudBot or MaltBot. And he's shipping like crazy. He's getting a lot of things done, and he's completed projects more than companies and teams would complete in years. In his blog, he said, Agentic engineering has become so good that it now writes pretty much 100% of my code. So the AI agent basically writes 100% of his code. So how does he do that to build such a viral product like OpenClaw? Just using AI agents. Let's try to learn from him to see what workflow he uses. So first, let's start with things to avoid. So I have summarized the recent posts from his blog, and here I give you the conclusion. You do not need to elaborate a lot on your prompts. So people online, they're gonna tell you to basically have certain prompts for certain models, and they even try to sell like prompt templates. And this is actually a scam. So never buy a prompt template on the internet. First of all, large language models are undeterministic, meaning that if you ask the same question with the exact same wording, in some settings, it can give you a completely different answer. Moreover, the context also plays a role. The context is not only the prompt. The context can have the history of the messages, your profile, some other information that the LLM or the agent has access to that is different from the prompt. So this will also affect the quality or the response. Moreover, different models or different LLMs will give you different results. So it's not reproducible. The idea here is that you do not need to have elaborate prompts anymore for agents, because agents are now very good in searching for context. So they're gonna go to files, they're gonna search files in the code base, and they're gonna ask you for any information that doesn't exist in the code base or doesn't exist in the current context that the LLM has access to. The second thing to avoid is sub-agents. So the idea of sub-agents is, here you have your main agent. So when the main agent wants to perform a task, it's gonna spawn a separate agent, and then this sub-agent will return the result, and then the whole context of how it came into this result will be wiped out. First of all, okay, you isolate the context, but at the same time you lose some parts of the context that might be helpful in the overall task. This is one thing. The other thing is that the coding agents are gonna spawn these sub-agents without your control. You cannot know what's happening or what context is basically being passed between these sub-agents, so you lose the control over that. That's why he suggests that whenever you want to have some isolated task, for example, let's say you want to search for something, and then you just need to return the result, but you do not need the context of how this result has been fetched. You can just do that in a separate agent. So you have one agent for one task, and then you just open a new terminal and have your new task in just a new, completely new context. And then you can just take your findings and either apply to the code base directly, where the first agent is reading from, or you can pass it manually to the first agent. So yeah, so this is the main idea. So the third thing that he says to avoid is wrapper tools. So wrapper tools basically are like tools or software that tries to wrap the existing coding agents like Claude or Codex, and they try to give them extra capabilities to vectorize the code base and to save the code base in an index. With the current agent capabilities, they actually are able to search the code base very well. So you do not need to have additional wrappers around these LLMs. So now what about code quality? So if AI is going to write 100% of your code, then probably the code quality is not going to be that great, right? So here he gives some techniques or some ideas on how to control the code quality as much as possible. So first is the blast radius thinking. So the blast radius thinking is the following. Think of your code base as this space of code or this space of features and files. So a feature, for example, lives in a subset of these files. So it lives here in the space. Another feature lives in another subset of files in your code base. And here, for example, here is like a third feature. The main idea is that you shouldn't make changes or multiple changes at the same time to regions of your code base that intersect, especially when you're using parallel agents at once. So this is agent 1, this is agent agent 2. So agent 1, for example, can be working on this region. Agent 2 could be working on this region. The main thing is that they should be independent, completely independent. If they're not independent, it doesn't work. Also, another important idea is that these changes or these regions should be small enough for the agent to be able to comprehend and to tackle efficiently. So the larger the region gets, the more difficult for the agent to maintain the quality that enables it to implement that feature. So that's the idea. Another thing is that he commits directly to main. So he just has basically a linear workflow. He doesn't use like git work tree. And this tends to be better than asking the agent to work in multiple branches and then do merges, because this introduces merge conflicts and additional overhead that complicates the process. Okay, now the third thing are tools. So CLIs are better than MCPs. The idea here is that MCPs are chunks of text that live in the context. So let's say this is your full context. This MCP definition should live inside your context. Another MCP also lives here. Another MCP also lives here. So they eat from the context, and also it's unnecessary. For example, if the model is not using any of these MCPs, this data is gonna still live in the context. So it's gonna cause you extra tokens, and it's also gonna degrade the quality because it's just occupying the context that could be used for something else. So the better idea that he introduced is the use of CLIs. So instead of having MCP's definitions in the context, what you do instead is that you just give it the name of the CLI and what does it do. Then if the model tries to use the CLI in some way, it might get an error, for example. And once it gets an error, it's going to go and try to check the documentation of that CLI. And then it's going to come back and use the correct command. So the second thing is that he uses multiple terminal with Ghost TTY. This is just like a multiplexer for using terminals in multiple windows. Actually, I don't use it. I just add a new terminal, but turned out that like a lot of people are using it. And he says that it's better user experience when using this terminal. Okay, now the context. How does he manage the context? As we said, brief prompts. This is one thing. The second thing is he uses screenshots. He just like screenshots, for example, the result, and he give it back to the agent. And LLMs now have decent visual capabilities, so they can read text from the image, and they can also analyze how that fits to the implementation of the current feature that we're building. So the third thing is test same context. This is very important. When you implement a feature, ask the LLM or ask the agent to immediately test it, because it has all the context it needs to test this feature. So it's beneficial to immediately test that and solve any issues that it might encounter. That's the idea here of the context. Parallel workflows. He basically have multiple agents working in parallel, either in one code base or multiple code bases, 3 to 8 agents in a grid, scaled by blast radius. Also atomic commits. Atomic commits is also very important. So this means that one commit, one clear change. Every commit has one exact purpose, which is implementing something, enhancing something, solving some bug, and so on. And now the main philosophy here, or the main takeaway from this video, is that just talk to it, explore, develop intuitions of how it works over time, literally like any other skill. Just like you talk to it and you try to improve over time. Don't just like blindly listen to the advice on the internet of how you should have your setup. Experiment yourself. Take those like tips from the people who are successful. So this is a proven workflow. And also, as we discussed at the beginning, less is more. So the less complicated your workflow is, the better, the more you can get done, and the better your overall result will be. There is actually one catch I want to explain. But before that, let's check comparison Claude Code versus Codex. So he uses Codex. Why Codex? First of all, it has more, around 100,000 tokens in the context. It first reads files before writing. So it tends to explore the code base more thoroughly before it does some change. The one-shot accuracy is higher. So this is GPT 5.2 and he's comparing it to Claude Opus 4.5. It also handles large refactors, better than Claude Opus 4.5. That's his experience. So he has shipped a lot of product and most of them are in production, like his trustable person. The CLI itself is implemented in Rust, which makes it faster and like more smooth experience than Claude Code. Okay, now let's go to the part that most of us won't like. So this is his token usage on Codex. So he has used 285 billion tokens in total. To put it in perspective, this is about 194,000 Harry Potter series, 400,000 Lord of the Rings, and 250,000 Bibles combined. So this is the amount of tokens he has used. And the usage cost for that is $51,000. So most of us won't have this enormous usage, but yeah, that's the idea. The idea is that he keeps Codex running for hours. So he gives it all the context it needs, all the tests that it needs to generate. The iteration keeps running until the refactor is done or until the feature is implemented. It's very similar to the RAG. off-the-shelf Wigem thing, but it's just done in Codex. So if we just take a look at all of that, we might be tempted to say that software engineering is solved, programming is not needed anymore. But actually there are some still difficult parts, and he only is able to do that because of his knowledge about programming and about his extensive experience of what looks good and what's not, and how to steer the model to come up with the best solutions. For example, here he mentions picking the right dependency and framework to set on is something I invest quite some time on. Is this well maintained? You want the agent to use libraries that are well maintained. How about peer dependencies? Is it popular? So will it have enough world knowledge so agents have an easy time? Equally, system design. Will we communicate via the WebSocket, HTML? What do I put into the server and what into the client? Often these are things that are a bit harder to explain to a model, and where research and thinking pays off. There's still the human part, there's still this experience of how these systems actually work. What are the design decisions? For example, if you don't know what he's talking about, you will not even ask the question whether to put some component on server versus client, for example. So if you don't know that, you will just maybe after 1-2 weeks get some like performance degradation. You will not even understand why this happened to begin with. But if you know from the beginning, you can just design and architect the system in a much better way. And yeah, so that's what he's talking about, like to do the research properly and the system design properly will pay off in the long run. So yeah, that was all. I hope you learned from it. Thank you for watching. See you in the next one. Bye bye.